So we've seen how to evaluate a classification model or a regression model. But what about when we build it in the first place? How can we design it so that it gives us optimal performance? Well, you might remember when we built our models, what we did was we split our data into a training set and a testing set. We took that training set, and here's an example here where we have a vector of features and we have a label that we're predicting. And we chose an algorithm that we wanted to use to create our model. And when we trained the algorithm, we specified a couple of parameters. Now, different algorithms support different parameters. They're not always exactly the same. But in this case, we used, for classification, we used a logistic regression algorithm, and for regression, we used a linear regression algorithm. Both of those support the same parameters. And the parameters that we chose to work with were the reg param, which is actually regularization parameter, and max iter, which is the max iteration. Now, regularization is a way of avoiding imbalances in the way that the data is trained against the training data so that the model ends up being overfit to the training data. In other words, it works really well with the training data, but it doesn't generalize well with other data. So we can use a regularization parameter to vary the way that the model balances that out. The iteration parameter is used to specify the number of iterations that we perform in order to produce the best model. So what can I do to choose the optimal values for these? If I just go with the values I used, off it goes, and it trains the model, and what comes out at the end of that is a trained model, which defines my function to predict. But I don't know if those were the right parameters. I don't know if it's actually going to be the best model I could have got. Well, what I can do is I can take my training data, and I can set up what's called a parameter grid. I've got a parameter grid here of all the combinations of parameters that I want to try out. So in this case, there are two different parameters that I want to try for my regularization parameter, and there are two different parameters that I want to try for my max iteration parameter. And I take my training data, and that's already been split, remember? So we took the source data, we split that into training and test. Then we take the training data, and we split it again. This time we split it into training and validation data. So this is called a train validation split. So we've got our training and validation sets of data, and we go off and we first of all train the model using the first combination of parameters. So off we go and we train that model, and then we can take our validation set and we can check that against the model and see how that performs. But then we carry on doing that with the same two splits of data, trying every combination of the parameters in the parameter grid. So I try that next combination, and then when I'm done with that, I go on to the next combination after that and try that out with the same data. And each time I'm training the model, and then I'm testing the model using my validation set, and I'm recording how that model performs. I'm looking at the performance metrics or the accuracy metrics for that model. And when I've finally done all of the different combinations that are in the parameter grid, I can take whichever one worked out to be the best out of those tests, and that's the model that I'm going to use going forward. So this way, I get a pretty good chance of trying different parameters to figure out which one performs best, and then get the best model to use going forward.